Okay, this is an answer key to help you with the formative quiz we did on percent composition, empirical formulas, and molecular formulas. So if you had trouble with any of these questions, this will help you determine where you went wrong and how to get the answers correct for our unit test. Okay, so the first question tells us two masses that, or three masses that really would have had to have been determined by experimental procedure. Okay, the only way we can know we have 0.9 grams and 0.16 grams is if we actually measure that on a scale. So that would be considered an experimental procedure. Okay, they do give you 2.5 grams for the mass sample, but we could have even calculated that knowing that half of it is 0.9 and the other half is 0.16. So what we're figuring out here is our percent composition. So it doesn't matter which one you start with. I'm going to start with calcium. Okay. We know the percent composition of calcium must be the mass of calcium over the mass of the total compound, which is calcium chloride. Okay? And don't forget, you need to multiply this by 100% because it is a percent. Okay? Now we're just going to plug in the values. We're given the mass of calcium being 0.9. And we're given the mass of the sample, which is 2.5 grams. So we're going to multiply this by 100%. Okay? And what you'll see is that works out to be 36%. Okay? You could complete the same calculation using the 1.6 of chlorine, or you could just say that you know 100% must equal the percent comp of calcium plus the percent comp of chlorine. Okay? It's only made of those two elements, so they have to add up to 100%. So that's the same thing as saying the percent composition of chlorine is equal to 100% minus the percent comp of calcium. So that's the same thing as saying the percent composition of chlorine is 64%. Okay? On the quiz, this question was out of 4 marks. You got 1 mark for showing me this formula. You got 1 mark for showing your work including the unit, so both here grams and percentage. And you got a 3rd mark for calculating one of the percentages, so calcium being 36%. You also got a 4th mark for telling me the mass percent of the other one. That means it wasn't required that you did the full calculation again, as long as you could tell me why you knew it was 64%. Okay? Let's move to the next question. The next question says, what's the mass percent of nitrogen and ammonium nitrate? Because you're not given any mass values, you know this has to be a theoretical calculation. Okay, so the first thing you need to know is what the formula for ammonium nitrate is, which is NH4NO3. And we're trying to figure out how much of the mass of NH4NO3 is contributed from nitrogen. Okay, so the first thing that we need to really calculate is the molar mass of NH4NO3, which we know is going to be the molar mass of nitrogen times by 2 plus 4 times the molar mass of hydrogen plus 3 times the molar mass of oxygen. Okay, if you add that all up, it's going to be 2 times 1401 grams per mole. That's off the periodic table. 4 times 1.01 grams per mole. And 3 times 16 grams per mole. These values are right off the periodic table. This is 2 because we have 2 nitrogen. This is 4 because we have 4 hydrogen. This is 3 because we have 3 oxygen. If you add that all up, it works out to be 80.06 grams per mole. Okay? So now that we know the molar mass of ammonium nitrate, we can figure out how much of that 80 grams is contributed from nitrogen. So here, we're going to calculate our percent comp of nitrogen, which is going to be 2 times the molar mass of nitrogen, because we have 2 nitrogen atoms, over the molar mass of ammonium nitrate. Okay? So we're just saying, if I know how much 1 mole weighs, and I know how much in that 1 mole nitrogen would contribute, we can figure out the percent composition. Again, this is going to be times 100%. So this is going to be 2 times 1401 grams per mole over 80.06 grams per mole. And again, multiply this by 100%, and you're going to get 35%. Again, this question was also out of 4, so you would get a mark for calculating the molar mass correctly. You would get a mark for this formula. You would get a mark for showing your work including units, so grams per mole and 100%, and you would get a mark for the final answer including units. Okay? So remember, you're always getting marks on questions for showing me the formula including units. Okay, the next question is an empirical formula question. So this is saying, find the empirical formula for a compound consisting of 29.4% calcium, 23.5% sulfur, and 47.1% oxygen. So the first thing we always do in empirical formula questions is we say we're assuming a 100 gram sample. Doesn't really matter what mass you assume. 100's easy because it's an easy conversion to grams, okay? So we're going to assume that so we can figure out mass and moles of each of these compounds. So knowing that, we know the mass of calcium must be 29.4 grams, because 29.4% of 100 grams would be that many grams. We know our mass of sulfur is 23.5 grams, okay, same thing. And we know our mass of oxygen must be 47.1 grams, okay? Now that we have three masses, we can figure out mole values. So how many moles of each do we have in 100 grams? So my moles of calcium is going to be my mass over my molar mass, okay? So that's going to be 24.9 grams divided by 40.08. You can look that up on the periodic table, grams per mole, okay? Which means we have 0.73353 moles. You want to keep a good number of decimals because this is just an intermediate calculation, okay? You don't want to lose your preciseness by rounding too much. We're going to do the same thing for moles of sulfur, so mass over molar mass, which is 23.5 grams, and if we look up the molar mass of sulfur on the periodic table, it's 32.07 grams per mole. Okay, this works out to be 0.73277 moles if you plug that in on your calculator. And we're going to do it again one last time for oxygen. Mass over molar mass. Okay, 47.1 grams divided by 16 grams per mole, which works out to be 2.94375 moles. Okay? Again, you can see I've been doing chemistry for a really long time. I'm always including my formula, always including my units. Okay? That's to ensure even if you make a misstep, your teacher can follow your logic and give you part marks. If you just are putting down numbers and not explaining it with units or formulas, it's hard for me to give you partial credit if you don't get the perfect answer. Okay? Next thing that we're calculating now that we know moles is our subscripts for each. Okay, and we know we calculate that by taking the moles of what we're looking at and dividing it by whatever is the smallest number of the three mole values. So in our case, we're going to look here. This one's our smallest. Okay, so we're going to take 0.73353 moles and divide it by 0.73277 moles, which is going to give us a number very close to 1. Okay, so we can assume 1 is our subscript. We're going to repeat this for sulfur. So moles of sulfur divided by moles of the smallest, which is going to be 0.73277 moles divided by the same number. So that's going to equal 1. Okay, and we'll do it one last time for oxygen. It's going to be moles of oxygen divided by moles of whatever is the smallest number, which is going to be 2.94375 moles divided by 0.73277 moles, which is going to give us a number, if you look, it's like 3.9999999, very close to 4. Okay, so based on this, we can say my empirical formula must be Ca subscript 1, which we don't write, SO4. So here's my empirical formula. On the test, you got a mark for writing, assuming a 100 gram sample, okay, and calculating the mass values, but make sure you write this statement out, that you will get marks for writing out that statement, because it explains where you're getting these masses from. You got marks for calculating the 3 mole values correctly. You got marks for calculating the 3 subscripts correctly. and you got a mark for writing the empirical formula correctly. So that's why it was out of 8. Okay? The last question we have, it says, furthermore, predict the molecular formula knowing the molar mass of the compound is 408.42 grams per mole. Okay, so the first thing we need to do is we know our empirical formula, which is up here. We need to calculate our molar mass of what our empirical formula is to figure out how many times does that fit into the actual molar mass of the molecular formula. Okay, so what we do here is we're going to take the molar mass of calcium, add to that the molar mass of sulfur, and add to that 4 times the molar mass of oxygen, which is going to be 40.08 grams per mole plus 3207 grams per mole, and 4 times 16 grams per mole, which works out to be 136.15 grams per mole. Okay? And that's our molar mass of our empirical formula. What's given to us up here is the molar mass of our molecular formula. So using those two numbers, we're going to calculate what our multiplier is. Okay, which is the molar mass of the molecular formula divided by the molar mass of the empirical formula. So the molar mass of the molecular formula is given to us in the question, 408.42 grams per mole. We're going to divide that by the molar mass of the empirical formula we just calculated. We get a number very close to 3. Okay? So that means my empirical formula's mass can fit into the molecular formula 3 times. And because we know the empirical formula is just the simplest ratio, we need to take those subscripts and times them by 3 to get what the actual molecular formula is. So it would be Ca3S3O12. Okay? You may also have noticed, though, that SO4 is a polyatomic ion, so it also would be correct, if you notice that pattern, to write it as Ca3SO4, 3. Because we know sulfate likes to stay together as a unit. But you got credit for either of these. So this question was out of 5. You got 1 mark for calculating the molar mass of the empirical formula correctly, 1 mark for your formula, 1 mark for showing your work, including units, and 1 mark for calculating the correct multiplier. You also got a mark for properly writing the molecular formula. So hopefully this will make those questions make more sense. If you need any extra help, come see Miss Hoover at lunch or after school.